So this is the review for the quiz for tomorrow. We will give you all the rules that you see here. Okay, so we're going to give you the recursive formula for both arithmetic and geometric, and we're going to give you the explicit formula again for both arithmetic and geometric. So determine if the following secrets are arithmetic, geometric, or neither. Understand that arithmetic has to be dealing with adding or subtracting a common difference, and geometric is going to be dealing with either multiplying or possibly dividing some sort of common ratio. And neither is neither. So the idea is to look from one term to the next. Can you find a pattern? In this case, when I get from 3 to 1 and from 1 to 5 and from 5 to 9, I can see that I'm adding 4 from the previous term to the next term. This would be considered arithmetic. On number 2, as I go from one term to the next, I can see that from 12 to 6, from 6 to 0, and 0 to -6, I'm subtracting 6 from the previous term before it. That's also arithmetic. On 3, I'm going from a positive to a negative to a positive to a negative. Right there, that should be telling you that you need to be multiplying by some value or dividing, but in this case it is multiplication. And every time you keep going from one number to the next, you're multiplying by a -4. So this then becomes geometric. And on the last one, I'm going from 2 to 5 to 8 to 13. I'm adding by 3. I'm adding by 3. I'm adding by, by 5. It's not a common difference. This becomes neither. Okay. So now it says determine the next 3 values for the following sequences. So if I'm looking for number 5, I've got 3, then 4.5, then 6.5, then 10.1.25. So as I go from there to there, I'm adding by 1.5. But when I go from 4.5 to 6.5, I'm not adding by 1.5. So I must be doing some multiplication. So the question is, how can I figure what I'm multiplying by? It's not so obvious just by looking at the numbers, or maybe it is, which is great. If you're not sure what you're doing, then you want to use your calculator and see, well, if I were to go backwards, could I basically take those numbers, divide them, big divided by small, and get some ratio that when I go again, the second number or the bigger number divided by the smaller number, do I get a common ratio? You're going to want your calculator for sure. So let's see. If I start that last number, which is 10.125, and I divide it by the number prior to it, which happens to be 6.75, you get a ratio or a common, really ratio in this sense of 1.25. Well, what if I take the 6.75, the third term, and I divide it by the second term, 4.5? Do you get that same common ratio? And you do, I just didn't put the decimal. Let's try this again. 6.75, somehow that decimal didn't get in there. 4.5. There we go. There's that common ratio. Just to be sure, I'm going to try one more time. I'll take second term. I'll divide it by the first term, and you'll notice that you get that common ratio. So this is a multiplying by 1.5, because remember we divided backwards. So essentially what's happening here is going from left to right, I'm really multiplying everything by 1.5, which means I'll go back to the calculator. You should do that too, or just trust me that when I do 10.125 multiplied by 1.5, I get 15.1875. And then when I multiply that by 1.5, I get 22.78125. And when I multiply that by 1.5, I get 34.17185. Again, feel free to do that on your calculator, but those are the numbers that you get. Okay, this next one, I see whole number, fraction, whole number, fraction. The whole numbers appear to be going down by 1. The fractions appear to be going down on the numerator just by 2. Well, what you can do is a couple of things. You can say, well, let's see, 8. If I turn 8 into halves, wouldn't you agree that 8 is just 16 halves and 7 is just 14 halves? There, hopefully you see a pattern. Remember, this middle value, 15 halves, is still what it's supposed to be. This one is 13 halves. You should totally see a pattern. You're subtracting by 1 in the denominator each time, or really going down by a half. So if I do 16 halves, 15 halves, 14 halves, 13 halves, this would become 12 halves. This would become 11 halves. This would become 10 halves. But if I want to follow the pattern, isn't 12 halves just 6? And isn't 10 halves just 5? Okay, so now it really looks more like the pattern. 8, 15 halves, 7, 13 halves, 6, 11 halves, 5. Okay, so you're basically subtracting by half. You could have done it by decimals also. I think other kids are doing that. In other words, they took the first value was 8, 15 halves ends up being 7.5, and then 7, 13 halves becomes 6.5, and they see the pattern that way. And then they'd say minus a half again for 6, minus a half again, and then minus a half again. There you go. We're looking for the common difference. It's a multiple choice question of this particular sequence. So hopefully you notice, and I'll use the positive numbers because I think they're just easier to work with, but from 4 to 9, I'm increasing by 5. From 9 to 14, I'm increasing by 5. And in fact, from -1 to 4, I'm increasing by 5. So you're increasing by a positive 5, which is not arithmetic, which does not have a common difference. Well, 3 to 7 is up by 4, up by 4, up by 4. That is. From 2 to 4 is up by 2. From 4 to 8 is up by 4. Wait a second, that's not arithmetic. Let's just double check the other ones. From this one, 2 to 1, I'm subtracting by 3. From -1 to 4, I'm still subtracting by 3 or adding a -3. That is arithmetic. From 2 to 4, up by 2, up by 2, up by 2. So it is in fact the one that you had to multiply by 2. That actually happens to be geometric. Which of the following is the explicit formula, the more powerful formula for this particular sequence? So we're looking for the sequence. Hopefully you realize it's going up by 4. So it happens to be an arithmetic. Your first number, so this happens to be your common difference. The first number, your a sub 1, is 3. Well, to get any value, we know we have to start with 3. Choice 1 is a of n equals 3 plus blah, blah, blah. So that's a possibility. Choice 2 is beginning with a1 of 4. Well, that's not true. Choice 3 and choice 4 are both beginning with a sub 1 to be 3, so those are okay. My common difference is positive 4. And what ends up happening, though, is the common difference has to be multiplied by 1 less than the term value you want. So it's going to end up being this one if you match it against your formula, a sub n, right? Here's your formula for explicit, a sub n equals a sub 1 plus the term before the one that you're dealing with times your common difference. Okay, so for sure, you're not multiplying n times 1 times the first term, and it's not minus. So that's enough to get rid of those. Okay, write a recursive and an explicit for this particular formula. We need to know which is which. So you need to say R for recursive or write the word recursive, it doesn't matter. But I need to know that you know. So the recursive formula basically deals with having to know your common difference. And hopefully you realize that from one number to the next, I'm adding a -12 or subtracting 12, whatever you want to call it. So you can use your formula sheet, but just know that for any value, for any term, as long as we know the term before it, all we have to do is add a -12, or I'm going to say -12. And we also understand that in this particular sequence that the first term is really 28. So that's what we're looking for your recursive. Your explicit, sorry, I put an R. Your explicit basically says, okay, well, for the term value that I want, I better know my first number. My first number is 28. And then from there, what I'm going to have to do is take the n minus 1, and I'm going to multiply that thing by -12. It has many more common differences that you need. we want to find the 35th term for that particular problem. So that should be okay as well. We've got the explicit formula that we're going to use. So what is the value of the 35th term if 28 is the first term and we need one less of those common differences? Essentially what we're saying is to get out 35 places, if we start with that first number, we just need 34 more of your common differences. I'm not going to bring the calculator up. I think you should be able to do this on your own or just kind of trust that we've got this right. What ends up happening again is if I keep going, this becomes 28. And when I multiply 34 and negative 12, actually, I don't even have that part on my paper. So what I'm going to do is the whole thing. So a of 35, when I type in 28 plus 34 times negative 12, you get an answer of negative 380. I will go back to the calculator for a second because I wanted to know that value. When we multiplied the 34 of the common differences of the negative 12s, this becomes negative 408. So really what I was hoping to do here is kind of jump up and say this right here is negative 408. So the 35th term was the first term minus the 34 more common differences. Bottom line, that's your answer. Okay. Recursive and explicit formula for this. Well, this one is not arithmetic. I'm not adding anything to get to the next one. I'm actually multiplying. I notice that the bottom is all being multiplied by 2. So if I multiply 1/2 times 1/2, I get 1/4. If I multiply 1/4 times 1/2, I get 1/8. And 1/8 times 1/2, you're going to get 1/16. So we've got this being the common ratio. We've got our first term being 1/2. When we start with the recursive formula, and again, feel free to go back to the formulas that we give you, we know that for any number, any term value, a sub n, we know that we need to know the number before it, a of the n minus 1, the number previous to a sub n, and we're going to multiply that by 1/2. The explicit, the one that we actually use to solve the problem, says for any value, I know my first term right now, which happens to be 1/2, and I'm going to multiply that by my common difference or my common ratio, which is 1/2, but then I want to have one less number or one less number than of how many terms I want to get out to. So if you want to find the 8th term of the sequence from problem 12, and express our answer as a fraction, we say, okay, well, I want to find the 8th term. So my n happens to be 8. A sub 8 equals 1/2 first number, first term, times common ratio, but I need 7 more of those. This one I will show you on the calculator, especially because I want you to have your answer as a fraction. So here, let me clear this. So we're saying first term is 1/2. I'm going to put parentheses because I'm going to multiply the first term by the common ratio, and I only needed 7 more of those. So this answer comes out as a decimal. We want the fraction answer. It asked you for the fraction answer. So all I would do is go to my math button, hit choice 1, which is fraction, hit enter again, and realize the answer is 1/256. So your 8th term out is 1/256. So this then becomes 8th term is 1/256. Okay. In an arithmetic sequence, the 30th term is 76. The common difference is 7. What's the first term? Well, if we kind of set this up as the explicit formula, we can say, okay, well, my 30th term, a sub 30, is going to be my first term, a sub 1, plus 1 less of the 30 that I'm going out times the common difference. Well, let's substitute some stuff in. We know that a sub 30 can be replaced with 70. We know that if n is the 30th term, then the n minus 1 is the 29 more that we need. And again, we don't know a sub 1. That's what we're trying to find out. So we're going to replace the 30th term with its value. The value out 30 places is 76. I don't know my first term, but I know I need 29 more of those common differences. When I start doing the math here, what ends up happening is I get 76. My value at the 30th term is going to be, whoopsie, a sub 1, my first term which I'm looking for, plus 203, the product of 29 and 7. Well, how do I find my first term? Just subtract 203. Turns out that my first term, a sub 1, happens to be negative 127. That means in my sequence, negative 127 is my first value. Every time I keep adding 7, I get different values, but when I get to my 30th position, that's where 76 is. Arithmetic sequence again. The first term is 4. The common difference is 8. Which term is 428? So basically, a sub n is 428. We need to know what n is. That we don't know. So I would probably set this up back into an arithmetic or an explicit formula again and saying, okay, well, a sub n equals my first term, which I know, plus how many more, which I don't know, of those common differences of 8. All you can really plug in right now is this. That's the only thing that you can plug in. So you know that the value at a sub n is 428. 4 plus. Now I'm going to do some commutative property here, just because I think it makes it look a little bit nicer. I'm going to actually do the commutative property with these guys, and I'm going to say, well, this really becomes plus 8 times n minus 1. I'm going to use the distributive property. 4 plus 8n minus 8. Then I realize that on the right-hand side, 4 and negative 8 is just negative 4 plus my 8n. And now this is all easy. I can add 4 to both sides. And I can say here that I get 432 equals 8n. Divide both sides by 8. Divide both sides by 8. And n comes out to be 54. So what does that mean? It means that 428 is the 54th term. And essentially all that they really want is this answer. Okay, next. Determine the 24th term if the first number is 3 and the r, the common ratio. This means it must be geometric. Okay, so ratio, not a d, not a difference. Express your answer in scientific notation and round the decimal to the 10,000th place. So if we were to set this up, we could basically say, alrighty, I want the 24th term. My first term is 3. My common ratio is 4, but I need 23 more of those 4s, right? Because the first number is already 3. I need 23 more. So if I go to the calculator here, and this one we'll do on the calculator, we're basically saying I know that it's going to be 3 times common ratio, and I need 23 more of those. And this is the answer that you get. We've got to round it to the nearest 10,000. So we have to look at the 5th decimal to round to the 4th decimal. 2.1111, and the power of 10 is 14. So how do we write this on our paper? You write it like this. The 24th term, or a sub 24, the value at the 24th position is going to be 2.1111 times 10 to the 14th power. This is your final answer. Let's try the next one. This guy, determine the 18th term of the sequence 1, 6, 36, 2, 16. Express your answer in scientific notation. Again, this is geometric as well, because hopefully you see that you keep multiplying by 6. Common ratio, this is geometric. Your first term happens to be 1. So we're looking for the 18th term. So the 18th term is the first term times the common ratio of 6, and I need 17 more of those, one less than that first term that we already have. So this then becomes, and you can do this on your calculator, but if you round this out, it ends up being that the 18th term rounded is 1.6927, whose power of 10, whose exponent of 10 is 13. Write a recursive formula if you're given the explicit. So to write the recursive formula, all you need to know is just your common difference, because recursive says for any place I want to go to, as long as I know the number before it, the an minus 1, all I have to do is add 3. That's as easy as that is. Write the explicit given the recursive. So we've got our a sub 1 right here. We've got our common difference. So to write the explicit, we just have to say that for any term that I want to get to, I know the first number, and I just need one less of those common differences. Now remember, you're multiplying by negative 10. You're not subtracting by negative 10. You can turn this over into that y equals mx plus b look, and I think that's kind of worth doing. Or if I actually distribute what's happening here, I could say, well, a sub n equals 2. And now I'm going to distribute. Actually, I'm going to do it this way. I'm going to put minus 10 and minus 1. I just did the commutative property. That's all that I did, right? I just switched the minus 10 with the parentheses and minus 1. A sub n equals 2. Distribute, distribute. And a sub n equals 12 minus 10n. This is fine. It didn't ask you to get there, but you should be able to. The y equals mx plus b look. And this is fine. I will take either one. They are identical. Some people actually might want to write this one as really what it looks like, the y equals mx plus b. So you would do negative 10n plus 12. That's good too. Okay. Winding it down. A sequence is given by the explicit formula. This is that y equals mx plus b. Write the recursive rule for the sequence. Now remember, well not remember, but here's a hint. List out the first few terms of the sequence first. We did these by graphing. So if you remember how we did these before, we said n stands for the position that you're in. First term, second term, third term, fourth term. So like first, second, third, fourth term. The a sub n stands for the value at that spot. But I'm actually going to do the rule here. They're telling you to get to a sub n, you're going to apply this rule each time. So if I'm going to do 10 times n plus 5, 10 times n, whoopsie, that doesn't look like a plus sign, plus 5, 10 times n plus 5, 10 times n plus 5. But when I plug in 10 times my first value, or my first position, 10 times 1 is 10, plus 5 is 15. When I plug in 2, 10 times 2 is 20, plus 5 is 25. 10 times 3, 30, 35. 10 times 4, 40, plus 5, 45. This is enough to help you see your the common difference you should know, but this is enough to help you see the common difference. You keep increasing by 10 each time. So your common difference is 10. You probably knew that already because that is your rate of change or your slope. But the first term, your a sub 1, is 15. So now you should be able to write your explicit formula and you should be able to say, okay, well for any value, any term that I want to get, all I need to be able to do is know that, it was just recursive or explicit? Recursive, sorry. All I need to know is the number before it and my common difference in this case, which is just 10, knowing that my first term is in fact 15. Okay? Let's try one more, or the next one, I should say. 21. So a sequence is given by the explicit formula a sub n equals 5 times 3 to the n minus 1. Write the recursive rule. And again, you can list out the first couple of terms for this. So when we do that, this becomes your n. This is going to be your 5 to the 3 n minus 1. This is going to be your a sub n. So if my first term is 1, second term being 2, or my first position is 1, my second position 2, my third position is 3, this becomes 5 times 3. In this case, 1 minus 1 is 0. And then when you do your calculator, if you remember that anything with the 0 power is 1, so it becomes 5 times 1, which is just 5. This becomes 5 times 3 to the 2 minus 1, or the first power. And then 5 times 3 the first is just 15. This becomes 5 times 3 to the 3 minus 1, or the second power. 3 squared is 9. 9 times 5 is 45. So what happens here? We know that the common ratio happens to be 3. The first term happens to be 5. The fact that we're going to be writing a recursive rule here, we're saying basically for any number, a sub n, as long as I know the number before it, I just have to multiply it by 3. And again, my first term is 5. Alrighty. Last question. The 45th term of an arithmetic sequence is 100, and the common difference is -2. Find the 17th term. So essentially, you need to find the first term to then be able to go out 17. So this is a little bit different from the ones that we've done, but I don't think it's anything that you can't do already. So we know already that the explicit rule would be a sub n equals the first term plus 1 less than how far we go out times the common difference. Where they're telling you that the 45th term, that is your n. The 45th term is 100. So basically, we'll kind of just do this. The 45th term is the first term that we don't know with 44 more of our common differences of -2. So then what happens is, well, what is the term at the 45th spot? And that value is 100. So 100 is a sub 1 minus 44 times 2, -2, which is minus 88. If I add 88 to both sides, 188 must have been your first term. So that's great. So now we know the first term. Can we find the 17th term? And of course we can, because now we can say, well, the 17th term is the first term plus 16 more of the common differences. So then what ends up happening, it's going to be the 17th term is 188 minus 32, or the 17th term is 156. All right, that's it. Just under 30 minutes for the video. So your quiz tomorrow is going to look very similar to this. Not as many questions, not even close. I think there's probably going to be about maybe 9 questions, 9 or 10. But you should know the difference between arithmetic, geometric, going from one term to the next, being able to be given a value, a of n, and find the first term, so kind of going backwards. I think you guys, I'm hoping you're going to be okay. All right, so we'll see you tomorrow.